Hey physicist, I'd like to give you a little example of the SQ3R note-taking system with our text. The SQ3R method stands for skim, question, read, recite, and review. The first part is skim. I want to look through a chapter or a section in just a couple of minutes. We're doing that with the idea of forming questions. Those questions become the basis of our reading. You can see here we want to read through any introductory remarks in a section. We want to notice the headings or subheadings that are listed in the text. Check for vocabulary, and these are often either bolded or listed in a different color inside the text. Look at the graphics, the pictures, and the captions. Those have been placed there for a particular reason. They illustrate points that the authors want to get across. And then the last thing is take a look at the end of section review. Most technical reading will have some type of end of section review. That can be very helpful in forming our questions. Here I'm starting with page 17 of our text, and this section is called Speed. Just below that you can see the introductory remarks. Read through those a little more closely, get an idea of what this section will cover. Next we see our section headings and subheadings. You can see this happens to cover the idea of speed. We have a subheading there, an example of speed, and the precise meaning of speed. Those those subheadings will follow throughout the chapter. Take a look also on the upper right-hand corner of the page, and at the beginning of each of the sections, our text is arranged so that we can see any particular vocabulary that's special to this. You'll also notice that in the text itself, that's listed in the body of the text with a different color. If you're reading something other than our textbook here, you may have to go back to the end of chapter glossary or index in the back of the book. Moving on to the next page, take a look at some of the graphics that are in here. Okay, here we end up having a graphic that illustrates some type of a movement of a car from one place to another. Important things will be the caption underneath there. Let's see some of the particulars in here. In technical reading, we can see here it actually gives solutions to a quick problem. 150 kilometers in 1.5 hours. We have a speed of 100 kilometers per hour. Other graphics would be an example down over here of a table. We can see this is looking at common units for speed. Let's move on along a little bit here, and we'll take a look at the end of chapter or end of section review, and that's found down here at the end of, let's see, just looking for my cursor. Yeah, we see section review. This one, it's more for reading comprehension. You can see this lists 3 commonly used units for speed. Not really good ones for making our questions, but make sure you can answer those as well. Okay, now let's start putting our notes to paper. Those who are familiar with the Cornell note-taking fashion will see similarities here. In the Cornell note fashion, generally you'll take notes in this section first, and then you'll come over with your cues over here. What we're going to do is actually come up with our questions first, and then we'll read to answer those questions. Give me an example of the questions I came up with as I read through there. Okay, hey, so what is speed? How is constant velocity different from speed? Okay, how is speed calculated? What are the units for speed? What does the word per mean? Okay, and what's the relationship between distance and speed? The last one I had was why is v used for speed? Okay. Now I'll start going through the text and read to answer those questions. Okay, my first question is, hey, what was it? It was, what is speed? Okay, so I'm going to read and then recite or put those answers into my own words. Okay, so from the reading I read a definition, but to put it in my own words, I answered the question, what is speed? Speed is the rate that an object's position changes. That means something to me. Okay, I answered these other questions. Okay, how is constant velocity different? Different from just speed. Constant speed is speed that doesn't change. Okay, and we can end up seeing the other responses I had. These are I've recited in my own words and written it down what these things mean. I haven't just copied it out of the text. Now my notes can be more than just words. You can see here on the right hand side I've put a graphic in there. Charts, equations are all things that can be used to help answer those questions. Okay. So we've covered most of the SQ3R. We've covered survey or skim, question, read, recite. The last thing we want to do is add our review, or I like to refer to it as a summary. And that is just kind of taking the time to put the ideas of our reading into just a few sentences, 2 or 3 sentences. You may want to step away from the reading for a little bit and come back to it. Hey, what was it I read? This is something that works out well if you have a study buddy or a small group that you're studying with. Come up with what that common ideas, or what were the big ideas you had from the reading. Mine, you can see, is listed here. Is that speed is the rate of an object's change of position. Units like meters per second are used for speed. And speed is equal to distance divided by time can be rearranged to calculate speed, distance, or time. Okay, there's kind of a practical run-through for the SQ3R system for our speed reading.